Hi everyone, welcome to the video lecture on measurements. We're going to be covering measurements for a few lectures and in the first two labs as well. And so to get started, what exactly is a measurement? A measurement is a quantitative observation. And almost all measurements involve two things. They both have a number, that's what makes them quantitative, and they have to have a unit. There are a selective number of measurements that are unitless, and those are they're not very common. And the ones that happen is when it's a ratio of two things. For example, if you look at something like specific gravity is the density of a substance divided by the density of water. And so when you look at this, you have units on the top that are density and units on the bottom that are density. And recalling from math, if you have the same on top and bottom, similar to having 3/3 equal to 1, if you have grams per milliliter divided by grams per milliliter, it's equal to 1. And so the units kind of cancel out. But almost all of the measurements that we're going to take will involve a unit. So what we're going to do in this video lecture is look at the number portion of it first, and then after that talk a little bit about units, and then in the second segment we'll talk about how to convert units and all of that good stuff. So moving on, what we're going to talk about first is the number portions. And so when we're looking at numbers, there's a couple of different things that we need to look at. First is, how do we express the number? Now, when we're expressing a number, typically you can just write it down. And in most of your classes, that's all that you needed to do. If somebody says the value is 12.1, you'd write down 12.1, done. But what happens if the measurement is 12 million? Well, if the measurement is 12 million, then you have a lot more to write down. And in science, what's true in chemistry is we sometimes use very, very large numbers, and we sometimes use very, very small numbers. And writing out all of these zeros becomes a little bit tedious. And so what we do to express numbers that are very large or very small is we don't use what's called floating decimal in some places, or some people just call it normal notation. We use what's going to be called scientific notation. And so if we're going to express ordinary, reasonably sized numbers, you can just use floating decimal or normal notation. However, if you're going to use large numbers, we're going to need to use scientific notation. Some people call this exponential notation. It's the same. And so if you are writing a number in scientific notation, what you're going to have is a value times 10 raised to some exponent. And so when we write a number in scientific notation, notice the base power is always 10. Technically, exponential notation, you can have any base that you want, but if it's scientific, the base is always 10. And so let's just take do a couple examples of how we would work this out. So if I wanted you to convert a number, say a number, let's do 12 million since I already had it written down. If we needed to convert this to scientific notation, how would you do that? Well, the number in front here is 12. We're going to get to the digits in a little bit, so let's not get caught up on those right now. But what I'm going to do is try to get rid of all these zeros. So if I want to get rid of all of these zeros, I'm going to start here with my original decimal point, and I'm going to count over how many times I'm moving it. 1, 2, 3, 4, 5, 6. Now, do I stop there? The rules for scientific notation say that the number that you write must be greater than 1, but less than 10. So if I stop right here, my number would be 12. 12 is greater than 10, so I can't. I have to go one more over. If I go one more over, my number is now 1.2. That is greater than 1, and it is less than 10. If I go one more time, which I don't want to, my number would be 0.12. This one would be less than 1, and that's making the value too small. So I'm going to stop here at 1.2. Now I'm going to go times 10, and times 10 to the what? You have to look at how many times you move the decimal over for the powers of 10. So I move the decimal over 1, 2, 3, 4, 5, 6, 7 times. So I would write this as 1.2 times 10 to the 7th. And that would be my correct answer. Now, your calculator may do this for you. It depends on what calculator you have. And if you don't know how to use your calculator, please sign on to an office hour. It's hard for me to know what everybody's calculators are, but most calculators have a button that says mode. And if you go to mode, some of it will be scientific, or you might see floating decimal, or you might see engineering as different modes. This is the one that does scientific notation, and this would be our floating decimal, or you might see normal, meaning the same as floating decimal. So I have just an old TI 30X that I use the most. And on mine, I actually have a scientific engineering button on there. And so if I put my number in of 12 like this, and then I hit this function, hit that button and hit equals, it actually moves it to show me this. Now, it doesn't actually show me this on your calculator. If you're in scientific notation, it never shows the base of 10. So if you're in your calculator, it will usually just show up and be this. Sometimes there'll be a little e there for the exponent, but it depends on the type of calculator, whether this will even be there or not. So it may not be there. It's important to know how to use your calculator. So spend some time with it and see that you can get it to work. And again, if you're having trouble, you can always join into an office hour and show me your calculator. I can figure out most. There's a few I might have trouble with, but usually I can figure out how to get things done on there. So let's just try one more example before we go anywhere. What if a number looked like this, 0.000056? And I asked you to convert that to scientific notation. Again, you're going to want the number that you write down to be between 1 and 10. So I'm going to move my decimal to here. I don't want to move it any other place. That is the place it has to go, because now my number would be 5.6. If I go over one more, that's too many. I'm going to be at 56. And if I go to here, I'd be at 0.56. So neither of those are the correct places. So once I'm at 5.6, what is my exponent? Well, just look at how many times you moved your decimal over. 1, 2, 3, 4, 5. Now, I don't want to say that's times 10 to the 5th because I didn't multiply that number by 10 5 times. I actually multiplied that number by 1 over 10 5 times. And so if I'm making the number get larger, I need to make my exponent get smaller. And so this would be a negative exponent. Now, a lot of people have trouble with negative exponents, so I want to be clear. This does not mean the number is negative. What it means is that the number is less than 1. And 0.000056 is a value less than 1. And so when we express it in scientific notation, it needs to have a negative exponent. You can kind of think about it as being a base number times 10 to the 0 power. Now 10 to the 0 power, remember, is equal to 1. So if your value is greater than 10, you're going to have a positive exponent. If your value is less than 1, you're going to have a negative exponent. This has to get larger if it's greater than, to represent a value greater than 10, and that has to get negative if you have a value that is actually less than 10. So there are some to practice on in the homework assignment. Make sure you practice with your calculators. I know a lot of people think they know how to use their calculators, and when they find out they couldn't is if this was traditional in class, they would be taking a quiz and they would figure out they don't know how to do it. So I can't stress enough that learning to use your calculator properly will save you so much time throughout the whole rest of the course and as you move forward in all chemistry classes. So take the time and know, and if you don't know, just ask for help. Okay, so that is what you need to know about scientific notation. Now the second part of talking about numbers is B, how many digits do you show? Now, typically, if you do a mathematical calculation using your calculator, it will show you a lot of digits, unless it comes out to be an exact value. You don't always need all of the digits that, or want all of the digits that your calculator is showing. So we have a system of what is called significant figures that has a series of rules related to measurements and how the measurement is taken that tells you how many digits you should be showing. Rules that regulate or tell you the number of digits. Now, all of these rules are covered in Lab 1. So I'm not going to cover them here again, but you're going to see all of these rules in the first lab, which you're going to be doing this week as well. So go through lab number 1, the materials in chapter 2 of the TRO text, but you can find the videos that explain these in more detail with lots of examples. Now, significant figures is an important thing. I don't mean to dismiss it by not covering it in detail right here, but what you need to know is you must follow these significant figure rules from this chapter on for the rest of the semester. So I'm not always going to tell you, make sure you follow significant figure rules. It's assumed you will always follow significant figure rules for all problems all the way through the semester. So a little bit of time invested right now to know what you're doing will help you greatly throughout the rest of the semester. The only thing I wanted to talk about in more detail right here that I'm not sure lab number 1 does in too much detail is rounding. So if you have a value, something like 1.57, and I tell you to round this to 2 digits, 2 digits means I'm going to keep the 1 and I'm going to keep the 5. I need to drop the 7. We're going to use the simple rounding rule of if the value dropped is 5 or greater, then round up. If the value is less than 5, don't round up. So 1.57 would be rounded to be 1.6 to 2 digits. If I had a value of 1.54, I would round it to 1.5 to 2 digits. Now, technically, that's not really the rule. The real rule is a little more complicated. It's just that that's a lot of detail to pay attention to at the start, so we're going to start simple. The real rule says if the value is greater than 5, round up. If the value is less than 5, don't. And if the value is 5, you have to look at the digit after it. If the value you have to drop is 5 and the next digit is even, the rule says round up. And if the next digit is odd, the rule says don't round up. So it splits the 5, 50-50 chance kind of thing. But we're just going to say 5 or greater, round up. Less than 5, don't round up. Now, rounding with significant figures is a little more challenging than people might want it to be. And again, this is covered in the lab, but just to point out some places where people go wrong is what if I asked you to round 199 to 1 digit? Well, a lot of people would say, well, I'm going to keep the 1 and drop the 9, so I'm going to round it to 2. Now, the problem with that is that 2 is not the same as 199. So for example, if somebody owed you $199 and said, I'll round it up and give you $2, you would not go for that. If you wanted to round 199 up, you would have to round it to $200. So sometimes you have to add zeros to maintain the magnitude of the value. Now, this is the beauty of scientific notation. The beauty of scientific notation is you're not going to need to do that. If I needed to say 1.99 in scientific, 199 in scientific notation, it would be 1.99 times 10 to the 2, right? This would be here. And now if I wanted to round, I could just say 2 times 10 to the 2, which is 200. So using scientific notation is sometimes really helpful for not dropping the magnitude of the number or increasing the magnitude of the number when we're rounding. I'm going to just leave it at that, and we'll come back to much more detail later on throughout the whole course of the semester. We'll practice this with every problem that we're doing. We'll look at sig figs, we'll look at rounding. So it should make a lot more sense to you as we actually have problems to apply it. Okay, so I'm going to stop here, and this is just on the number portion. There'll be a second video talking about units for you to watch that's covering in chapter 2 as well.